Hi, this is Mrs. Rodriguez, your Algebra 2 teacher. This video is about lesson 9-5, and it's all about hyperbolas, okay? Go ahead and share my presentation with you. All right. So, talks about equations of hyperbolas, okay? And these are just a couple of examples of what the parent function, I guess you would call, of a hyperbola. So this is like a horizontal hyperbola, okay, where the vertex and the foci are along the x-axis, and this would be a vertical hyperbola where the vertex and the focus are on the y-axis, okay? And then we have the vertex are the endpoints here. Okay, it's kind of like the vertex of each of the parabolas. You're going to have two vertex and then two foci as well. And then you have what's called the two axes of symmetry, and those are called the transverse axes. So that would be this one here, and then over here would be this one here, and this one here. Basically, the transverse axes are where kind of enclose the hyperbolas there, okay? And then the conjugate axes are the axes are perpendicular at the center of the hyperbola. Okay, so we need the center in order to be able to graph a hyperbola, and then this would be the conjugate axis, okay, and then up here for this one, okay. All right, so we need to know these equations of hyperbolas, and these equations are used only when it's centered at the origin, okay? So in other words, the center point has to be 0, 0, okay? When that is the case, then if it was a horizontal hyperbola, then you would use this equation. If it was a vertical hyperbola, you would use this equation, okay? And then, as with all ellipses, there are several important relationships among the parts of the hyperbolas. There are two axes of symmetry, and the values of a, b, and c are related by the equation c squared equals a squared plus b squared. So this will be important as well. All right. So, first example says to write an equation for a hyperbola with vertices at 6, 0 and -6, positive 0, and then foci at positive 8, 0 and -8, 0. So the first thing you need to do is find the center, okay? We need to find that center point, okay? Now, since we're given the vertices are positive 6, 0, and -6, 0, where they are both the same distance from the origin, okay? So this hyperbola is centered at 0, 0, okay? And then the next thing we need to do, once we have the center, is we need to find the values of A, B, and C. Okay, we need to find the values of A, B, and C. So A is the distance between the vertex and the center. Okay, so we know that the vertex is positive 6 and 0. So if we're looking at a little quick graph of this, it tells us that the vertices are positive 6, let's say that's over here, and -6, okay? So the vertices are here, okay? So the center, they're the same distance, that's why this is the center. So if we're saying that A is the distance between the vertex and the center, okay, then A is going to be 6, okay? 6 units away. C is the distance between a focus and the center. The focus is at -8, and positive 8, okay? So the focus is 8 units away from the center, okay? So that is the value of C, okay? Now we need to use that information to solve for B, okay? And we know that c squared is equal to a squared plus b squared. So we're just going to plug in the values that we have. We know c is equal to 8 and a is equal to 6. So I need to solve for b. So this would be 64, this is 36, plus b squared. So then I would subtract here, and I end up getting 28 is b squared, okay? So now the last thing is I write my equation, okay? So last thing is my equation. So remember that it's centered at 0, and this is going to be, they're like this, the hyperbolas. So this is a horizontal orientation. So the equation for horizontal orientation is x squared over a squared minus y squared over b squared equals 1. So now I'm just going to plug in my values, okay? So I have x squared, and I know a squared. So if a is 6, I would square that. And then y squared and b, I just figured out, or b squared is equal to 28, okay? So I can simplify because I know what 6 squared is. That's 36. And then I still have y squared over 28 because I already solved for b squared. Okay, so I leave it as 28. It's not 28 squared, okay? And then that is your equation, okay? All right, so let's look at the next example. It says here that the asymptotes for a horizontal, okay, it tells you here a horizontal hyperbola are y equals 7 over 9x and y equals negative 7 over 9x. And then the vertices are 9, 0 and negative 9, 0. And again, it says to write an equation. All right, so first thing, just like the last time, we need to find the center, okay? So we need to find the center, okay? Well, we can see that the vertices, if we just did a real quick sketch, the vertices are positive 9, and positive 9, 0, and negative 9, 0. So again, our center is going to be 0, 0, okay? All right, so we've got our center. So then the next step is to find the values of a and b, okay? So we need to find a and b, okay? Since this is a horizontal hyperbola, because it told us that in the problem, okay, and we can see if these are the vertices, it's going to be going this way, okay? The equations of the asymptotes that we use are going to be y equals positive or negative b over a x, okay? So if you're wondering where I got that from, those are on page 624 of your textbook, and on the chart, it says equations of asymptotes, okay? So you need the one for the horizontal for a hyperbola when it's centered at the origin, okay? So it's given us the hyperbola, right? It says the equation of the hyperbola. It told us in the problem y is equal to 7 over 9x and y is equal to negative 7 over 9x. Okay, so b is the numerator, so the numerator is 7, and a is the denominator is 9, okay? So now we have a and b. So then the last thing that we do is we write the equation, okay? And since this is a horizontal hyperbola, okay, then we're going to be using the equation x squared over a squared minus y squared over b squared equals 1. okay? So now it's just a matter of plugging that information in. So we have x squared. I figured out a was 9, so I would square that. And then I have y squared, and I figured out b was 7. So I square that, and it's equal to 1. So I can simplify. So x squared, and then 9 squared is 81. And then I have minus y squared, and 7 squared is 49. Okay, so that is my equation. Okay. All right. And then now you're not always going to have hyperbolas that are centered at the origin, right? So if you have an equation or a hyperbola that is not centered at the origin, then you would use this information, okay? And once we have the center, then we know the values of h and k, and then we need a and b, okay? So if we're given an example, and it says to graph this equation, and it says to identify the vertices, the foci, and the asymptotes, okay? So once again, the first thing is we need the center, okay? So remember, center is HK, okay? And if we're looking at this, this is y minus 4 squared over, this would be, since this is y minus 4, we're using this equation here, okay, y minus k, I'll write it on the other side. But so we know this is going to be a vertical hyperbola, okay? So just keep that in mind. So I'll write it up here, I guess. So I have y minus k squared over a squared minus x minus h squared over b squared is equal to 1. Okay, so keeping that in mind, the value here is k. The value being subtracted is k. So what is being subtracted here? Well, 4 is being subtracted, okay? That is the value of k. So that is my y coordinate there, okay? And then over here, it says x plus 3, okay? So what is being subtracted is going to be h. So negative 3 is being subtracted. So my h value is negative 3. So now I know that my center is negative 3, positive 4. Okay, this is going to be my center point. Okay? All right. So then the next step is I need to find A, B, and C. Okay? All right. So I know from my equation, see over here it says a squared. I know that a squared is equal to 9. And I know b squared is equal to 25. So if a squared is equal to 9, a is equal to 3, right? Because 3 times 3 is 9. And if b squared is equal to 25, then I know b is equal to 5, right? Because 5 times 5 is 25. Now I just need to solve for c. But I know that c squared is equal to a squared plus b squared, okay? And a squared is 9, b squared is 25, so c squared is equal to 34. I need the value of c, so I need to take the square root, and this is going to be a decimal approximation. It's about 5.8. You just put that into your calculator, don't try to figure that out, okay? It's going to be about 5.5 and 8/10. So now I have A, B, and C, okay? So then the next thing I need to do is identify the vertices and the foci, okay? So my vertices, I'll start with that. Since this is a vertical hyperbola, if you look back, if you look back here, okay, the vertice, since it's vertical, we're using this h, comma, k plus or minus A, okay? So I'll write it over here. So I'm using this formula here. I've got H and then K plus or minus A. So that would be H, which is -3, and then the value of K, which is 4, plus A, which is 3, okay? Or -3 for H, and then K, which is 4 minus 3, okay? So that would be -3, okay? And then 4 plus 3 is 7. And then over here, I have -3, and 4 minus 3 is 1, okay? So those are my vertices. So I can plot those points. So that would be 1, 2, 3, and then up to 7. 1, 2, 3, 4, 7, okay? And then -3, +1. So those are my vertices, okay? All right, so then to find my foci, going back to this chart, for foci, it's right here. It's H comma K plus or minus C, okay? Plus or minus C this time, okay? So I will write it over here. Sorry about that. So for foci, I have H and then K plus or minus the value of C. So again, H is -3, K is +4, and then plus C, which we figured out was about 5.8. Or we have -3, H plus, and then K for minus C, which was 5 8/10. So this would be -3, and this would be 9 8/10. And then this would be -3 and -1 8/10. Okay, so I plot those as well. This would be -3 and then 9 8/10, so almost 10. And then over here, -3, -1 8/10, so about there. Okay. And then the last thing it says is to identify the asymptote. Okay. So my asymptotes. Okay, so my asymptotes is I'm going to use the equation y minus k is equal to plus or minus a over b times x minus h. Okay, where did I get that from? Okay, that is again from this table, equations of asymptotes. Since this is a vertical hyperbola, I'm using this equation here. Okay. All right, so then I just plug everything in. So I've got y minus 4 is equal to 3/5 because a is 3, b is 5, and then x minus h is -3, so this would be +3, okay? So then I would use distributive property here. Distribute 3/5 would be 3/5 x, and 3/5 times 3 would be 9/5. And then I would add 4. I need to isolate y. I would add 4 to both sides, and I end up with y equals 3/5 x plus 29/5. Okay, so what that means is I need to, this is where my asymptote is going to be one of them. Okay, so I need to graph this line. So my y, this is in slope-intercept form, so my y-intercept is at 29/5, so it's almost 6, okay? So my y-intercept, 1, 2, 3, 4, 5, 6, is right underneath 6, because it's almost 6, okay? And then my slope is 3/5, so I can go up 1, 2, 3, and over 5. 1, 2, 3, 4, 5, and put a point, or I can go down 3, and then over 5, and I could have a point there, okay? So that is going to be one of my asymptotes, okay? So this is a dashed line there, okay? And this keeps going. Then I have my other one, because this is plus or minus. So my other one, I'll just put a line here to separate, would be y minus 4 is equal to negative 3/5 times x plus 3. So here again, I would distribute, and it would be negative 3/5 x minus, right? Negative times positive is negative, so that would be minus 9/5, and I still have this y minus 4. So then I would add 4 to both sides here, and y would equal negative 3/5 x, and when I do negative 9 plus, or negative 9/5 plus 4, I get positive 11/5. Okay, so I have to do a little pre-algebra, adding, subtracting fractions there. Okay, so let me graph that line as well. So 11/5 is a little bit over 2. So my y-intercept is going to be a little bit over positive 2. Okay, and then my slope is negative 3/5. Okay, so I'm going to go down 1, 2, 3, and over 1, 2, 3, 4, 5. And I can also go up 1, 2, 3, and over to the left 1, 2, 3, 4, 5. Okay, and keeping in mind, it also has to cross my center point. Okay, so that's going to be about here. Okay, and it keeps going. So now I can draw my hyperbola here. I can graph it out. Okay, let me change my colors here. So this is my vertex. Okay, so, and I know it's going to be approaching the asymptote. Okay, like this, and this one as well. And then over here, I've got, it's going to be approaching the asymptote as well. That. Okay, and then my foci are inside, okay, of the hyperbolas there. Okay, all right, a lot of steps on that one. Okay, a lot of things to keep track of. Okay, all right, and that's all for this lesson. Hopefully this video was helpful to you. If you still have any questions about this lesson, please let me know, and I would be happy to help you. Okay, you can call, text, email, or stop by my office hours, and I'll be happy to help. You have a great day.